This is Dr. John Bergduff, and today we're going to look at two strategies for finding the greatest common divisor and the least common multiple of two numbers. We're going to look at one strategy in this video, and then the other strategy is in a separate video. Once you have a general understanding of what's meant by greatest common divisor and least common multiple, you're ready to tackle fairly large numbers where it's not obvious what the answer is. But when in doing so, it's good to have something that's very methodical and step-by-step that you can follow to keep yourself on track. So this first method involves looking at the prime factorizations of the two numbers you're considering. Actually, that'll become important in the second method too, but this is going to focus on that prime factorization. And here are the steps. The first thing you do is when you have two numbers, you find the prime factorization of each number by using a factor tree or a more methodical approach. To find the greatest common divisor, list all the prime factors once that appear in both factorizations. Raise each factor to the lowest exponent to which it is raised in the two factorizations. To find the least common multiple, list all the prime factors once that appear in either factorization. Raise each factor to the highest exponent to which it is raised in the two factorizations. So the rules for greatest common divisor and least common multiple are nearly identical, almost the same words if you look at them, except you change both and lowest to either and highest, and we're going to see what all that means. We're going to do this by looking at both the greatest common divisor and least common multiple of 120 and 126. So step one says you have to find a prime factorization. And I'm going to do that with a factor tree. So 120, I can think of several ways to factor that, but I'm going to look at it as 20 times 6. 20 factors as 4 and 5. 6 factors as 2 and 3. The 4 factors is 2 and 2. The prime factorization of 120 is the product of the leaves on the ends of the branches of the tree. And I'll write those down when we get to the next slide. 126. A little bit more complicated number. It might take you a little longer to see what works there, but you might recognize that 6 would divide very easily into 120. 6, and then if all else fails, you might need a calculator. Maybe not. So 126 is 6 times 21. Factoring some more until we get only prime numbers. 6 is 2 times 3. 21 is 3 times 7, and the prime factorization is the product of the leaves at the ends of the branches. So I'm going to start on this slide by just writing down what those two prime factorizations should be before we look at the next step. 120 factored as 2 to the third times 3 times 5. 126 was 2 times 3 squared times 7. And now we're going to look at what the greatest common divisor is. So what you do is you look at the list of prime numbers that just show up in either one of those factorizations. 120 has some 2s, some 3s, and some 5s. 126 has 2s, 3s, and 7s. You only want to look at the prime numbers that show up in both of those lists. It's got to be in both lists. So, for example, there's a 5 as a factor of 120, but 5 is not a factor of 126. We're not going to use the 5. But there are 2s and 3s. And what you do is you list those two numbers, but you only list them once. It's okay to put a multiplication symbol in between them. And then you pick the lowest exponent to which each of those factors is raised. So what do I mean by that? Look at the 2s. There's 3 2's, 2 to the third power in 120, only 1 in 126. The lowest exponent to which the 2 is raised is a 1, 2 to the 1. Looking at the 3's, there's 1 factor of 3 here, there's 2 factors of 3 here. The lowest exponent to which the 3 is raised is again 1. The greatest common divisor is the product of 2 to the first times 3 to the first, and that means that the greatest common divisor is 6. Now let me show you how that's different if you do a least common multiple. So let me write these down again just so we don't forget them. 120 turned out to be 2 to the third, that's a terrible 3, times 3 times 5. 126 was 2 times 3 squared times 7. What you do differently for the least common multiple is you look at all the prime factors that show up in either factorization, any prime number that shows up on either list. So we're going to include the 2's, the 3's, the 5's, and the 7's. If it shows up even once in one place, you use it. So write down those numbers just one time. 2, 3, 5, 7. And it's okay to put multiplication symbols in between. And then for each one of those prime factors, you look at the highest exponent to which it is raised. So in 120, the factorization of 120, that you have a 2 to the third. In 126, you only have 2 to the 1. The highest exponent to which the 2 is raised is a 3. You pick the highest exponent. Likewise, among the 3's, you have 3 to the first, only 1 factor of 3 there, 2 factors of 3 here, 3 squared. The highest exponent to which it occurs is a 2. 2 to the third times 3 squared. Now, 5 only shows up once, and the highest exponent it shows up to is just the first power. So 5 to the 1, and the same is true for 7. That looks like 0.1. Oh, and I've made it even worse. Hold on. There. 2 to the third times 3 squared times 5 times 7. I think I might get a calculator out to do that and multiply all those things together. The least common multiple would be 2,520. And look for the next method. I'll show you the same, this exact same example, but using a different approach.